Still continuing with topic 1, we now move over to the section on exponents. Exponents is a simple section. It should come out for around 6, 7, probably 8 marks in the examinations. You would have approximately 3 problems ranging from easy to medium and then the difficult question. Introduction to exponents. Exponential notation is used to represent repeated multiplication. Now that may seem a mouthful. Exponential notation, we are using it when we come across something called repeated multiplication. If a single number or variable is multiplied repeatedly, exponents can be used. A simple example to show you how we're going to use exponents is as follows. Consider the following expression. If we have the variable a multiplied by a multiplied by a multiplied by a multiplied by a, you would notice that we have many a's being multiplied together. If we look at the a's being multiplied together, we now come across a more simplified way of writing this. It will be cumbersome to keep writing as follows. In order to come to a shorter way, we will say there is an a, the second a, the third a, the fourth a, and the fifth a. To simply put this, I can write it down as a to the exponent 5. This 5 shows that it is a multiplied by itself 5 times. You would agree with me that writing it in this way is much easier than this long fashion here. Let's move even further. I want you to consider the following expression. Negative 3a to the 4. Now mathematically that is incorrect in the way that I said it. We want to look at this expression over here and try to break it down to understand what does this expression consist of. Firstly, I will see there's something in the front there. This over here is the sign. It could be positive or it could be negative. In this case, it is negative. If I go further, this is the coefficient. The coefficient is the number in front of the variables. If I go even further, this a over here is something called the base. That a is the base. The 4 on the top is what we are going to be discussing. This is called the exponent, but you will normally hear me referring it to as the index. One index, many indices. So all we are going to be dealing out here is, you will understand that we are dealing with one index, many indices. So if I come across the word indices, you know exactly what I am talking about. This portion over here, a to the exponent 4. A to the exponent 4 is known as That's correct. It's known as the power. Whenever we see expressions, we need to understand that these or this is the way an expression can be written. Just to go over it again. That's the sign. This is the coefficient. This a is the base, which you will hear me referring to quite often as the base. This is the exponent or index, and this whole part here is the power. In order to understand exponents, we need to know our basic exponents. This will really be helpful. I think by now you should know most of them, or if you don't, try to remember them. For example, what I want you to do is, I want you to know that 2 squared is equal to 4. 3 squared is equal to 9. 2 to the exponent 5 is equal to 32, and on and on and on. If need be, pause and copy these basic exponents. You will be using them quite often. Laws of exponents. In your curriculum, you will come across various laws of exponents. You are required to know the law. You are required to apply the law. Let's go further to look at the first law. We are now dealing with the index law for multiplication. Index law for multiplication. Consider the following. A to the index m, or a to the exponent m. A to the exponent m multiplied by a to the exponent n. What do I have here? I have a law that governs multiplication. This here is multiplication. A is the base, index m, multiplied by a to the base, index n. I want to know, if it is multiplication, what happens to these indices? Now I want you to remember this. Whenever you multiply the same bases, all you simply do is you add the indices. In order to add the indices, we take the m, add it to the n, and we end up with a to the exponent m plus n. You will see exactly where we are going to be using this as we go further. The rule says when powers having the same bases are multiplied, the indices are added. Very good. The indices are added. Consider a few examples. Question number 1. Simplify the following. 2 to the exponent 4 multiplied by 2 to the exponent 5. Now in order to make this a bit easier, let's use a pen. If I look at an example like this, straight away I notice here there's a base which is a 2, there's a base which is a 2. These here are my indices, 2 to the 5, or 4, and the 5. According to the rule stipulated on the top, if the bases are the same, I need to go ahead and add the indices. The base is 2 to the exponent 4 plus 5. There's the 4, there's the 5, and 4 plus 5 is equal to 9. So this becomes 2 to the exponent 9. Now guys, remember this is the index law for multiplication. Let's go further. What about example number 2? A cubed multiplied by a squared. This is a simple example. The base is a, the base is a. Similar bases. Now this law only works when the bases are the same. In a case like this, I write down the base which is a, and what do I do with the exponents? Because it is multiplication, I add the exponents. It's 3 plus 2, which is equal to a to the 5. The way I remember it is I say multiplication looks very, very similar to addition. Simply turn this around. So I know whenever I'm multiplying, I add the indices. Let's go a bit further. There's a good example. This is a type of example that you should expect also in your examinations. This would be one of the easier questions in order to answer. 3a squared b cubed c multiplied by this part multiplied by this expression. Now what do I need to do here is, because it is a long question, I need to break up the question. I did it here with colors, but when you do it, try to break it up by using your pen to highlight the areas that you are looking at. Each one of these has a constant. 3, 2, 2. So straight away I can go ahead and say this is equal to, if I even do that, 3 times 2 times 2. So I know I finished off with that one, and that one. Next I see is an a squared, a to the 4. They are being multiplied together. Now whenever things are being multiplied together, it doesn't matter in which order it is being written, because 2 times 3 times 4 is the same as 4 times 3 times 2. It doesn't make a difference. So in a case like this, look at the blues. It's that times that times that. What do I do? The bases are the same. The bases are a. I simply add the indices. There's an index of 2. There's nothing written on the top here, but you know this is an index of 1. So it's going to be 2 plus 1 plus 4. And ultimately, guys, this is what your answer is going to be. Let's have a look at it. It's 3 times 2 times 2. 3 times 2 times 2. Look at the a's. It's a squared, a to the 4. I brought all my a's together. Look at the b's. B cubed, b squared, b. All the b's are together. And likewise, all the c's are together. Now it becomes easy for me to answer this question because 3 times 2 times 2 is 12. A squared multiplied by a, and remember here this is a 1 and this is a to the 4. I'll do one of them. It's a to the exponent 2 plus 1 plus 4. Very good. This I've got as 12. This is 2, 3, 7. Agreed. Now consider the b's. There's a b, there's a b, there's a b. Remember this is b to the 1. The bases are the same. I add the indices, and if I add the indices it becomes 3 plus 2 plus 1, which is 3, 5, 6. So I should be expecting b to the 6. What about the c's? Remember this is a 1 here. Bases are the same being multiplied. Your answer or your exponent becomes 1 plus 3 plus 2, also giving you c to the 6. Now, even though the example was long, if you broke it up, you should get the correct answer. Very good, guys. Let's go further. Now we're going to move over now to the index law for division. I have completed the index law for multiplication. I now go to the next law, which is the index law for division. When powers having the same bases are divided, the index in the denominator is subtracted from the index in the numerator. Basically what they are saying is, if you have a to the m divided by a to the n, where this is division and the bases are the same, what do I do with the indices? According to the rule, I subtract the indices. It becomes a to the exponent m minus n. Very, very simple to remember. I remember it this way. I say division is very, very close to subtraction. And that's how I go about remembering the rule. Simplify the following. We come across a few easy examples again. Example number 1. Simplify this. 2 to the exponent 4 divided by 2 to the exponent 3. This is division, guys. Straight away, you will find the bases are the same. What do I do with the indices? Those two indices. Of course, because it is division, I am going to apply this rule and I am going to subtract. So it reads 2 to the exponent 4 minus 3, and 2 to the exponent 4 minus 3 is 2 to the exponent 1. Whenever we see exponent 1, we do not need to write the 1. Your answer simply is 2. In the examinations, if you leave your answer as so, not a problem. You will still get full credit for it. Example number 2. Example number 2. A to the exponent 8 divided by a to the exponent 3. Again, fairly easy. The bases are the same. What do I do with the indices? Come, guys, if the bases are the same, what do I do with the indices? Do I add or subtract? I subtract. So it's a to the exponent 8 minus 3, and 8 minus 3 is 5. So it simplifies to a to the exponent 5. If I look at example number 3 is a combination of rule number 1 and rule number 2, the index law for multiplication and the index law for division. What I would suggest when you come across examples like this, or even longer examples, do not rush the examples by doing too many steps at one time. Take your time, do a step, and then proceed to the next step. In this case, what I will do is, if I look at the numerator is multiplication of same bases. I will simplify that first. So I will say a to the 4 multiplied by a to the 2 is a to the 4 plus 2, which is equal to 6. I bring down the a to the 3. I did not want to do too many steps at one go. So all I did was I simplified the numerator to bring it to a to the 6. And now straight away I see my second rule. And the second rule is the index rule for division. A to the 6 divided by a to the 3. Obviously the bases are the same. What do I do with the indices? The bases are the same. I simply subtract the indices and I end up with 6 minus 3, which is a to the 3. How's that for an example? Let's go now to another example. Hopefully we'll be getting some better examples. Whoa, there's something that looks good. Now this is definitely an examination type question. You are guaranteed to see something of this nature here as well. If I look at this example, even though it may seem long, I notice my numerator can be simplified. At this stage, my denominator does not need to be simplified as much, so I leave it as so. I concentrate on the numerator. If I'm doing the numerator, I will see that I have a 4 multiplied by a 2, which is 8. What about an a squared multiplied by a to the 6? Remember, concentrate on these two. It's a to the 8. What about b times b cubed? This is a 1, this is a 3, so it's b to the 4. So this is equal to 8, 2 plus 6, which is a to the 8, 1 plus 3, which is b to the 4. Now I write down my denominator as so, and guys, now I will go and I will divide. To cut a long story short in division, this 8 cancels off with that 8. I'm happy with that. A to the 8 divided by a to the 4. This is division. I subtract. What about b to the 4 over b squared? This is division. So I subtract 4 and 2. So the answer that I should have is, if I read down here, it's a to the 4. If I read down here, it is b squared. And your answer should be a to the 4 multiplied by b squared. An example like this, guys, don't expect too many marks. Maximum should be around 3 marks for an example like this. Beauty. Example number 5. Example number 5 is another typical examination type question. But here I see division. Now, there's no need to get worried about this. I want you to go back to earlier days when your teacher taught you something like this. He said, if you have a half divided by, let's say, 3 over 4, which is a fraction divided by a fraction. All he said was, you need to not do division, but you need to look at the bottom fraction, bring it to the top, but invert and multiply. So it simply became half multiplied by not 3 over 4, but 4 over 3. Ultimately, I converted division to multiplication. Now in maths I always say, if you're making a change, you must balance that change by making another change. In this case, I changed the division to multiplication. To balance the change, I took the 3 over 4 and made it 4 over 3. The simple rule is, to change division to multiplication, you invert and multiply. Invert and multiply means, my first step, I change this to multiplication. This is equal to, the first fraction remains as it is, no changes. The division changes to multiplication. I'm happy with that. What happens to this fraction? I have to invert it. Now remember, if I write it as it is, I actually change the question, which I don't want to do. So I have to invert by saying a to the exponent 5, b to the 8 divided by a to the 4, b to the 6. I simply inverted and I multiplied. And now, guys, I go ahead and multiply across. I can multiply this way and then multiply that way and simplify, or I can simplify down if I want to. In this case, I multiplied across. A to the 5 multiplied by a to the 5. It's 5 plus 5, which is 10. B to the 7 multiplied by b to the 8 is b to the 15, because I have 7 plus 8, which is equal to 15. The denominator, let me just show you the denominator. I am saying if I have a cubed multiplied by a to the 4, it's a to the 7. If I have b to the 4 multiplied by b to the 6, it is b to the 10. And now, guys, it becomes easy, because all I have to do now is to divide. Look down. Look down here. What about here? Look down here. This becomes a to the 10 minus 7, b to the 15 minus 10. The rule is you subtract, and your answer is a cubed b to the exponent 5. How's that going, guys? No problems? Easy? I'm going to leave this, ponder about this for a moment. Ensure that you understand how to go about solving a question like this. Are you happy with this one, guys? Okay, while you ponder, let's go to the next one. How's that for being clever? Now, guys, we're going to go over activity 1. As always, you are going to copy down the questions. Pause for a moment, try to answer as many as you can. In fact, try to answer every single one, and then go to the answer section. Activity 1, question will read, simplify the following. I think here we have 6 questions. You are required to copy these questions down. Leave adequate space, for the answers, and then you may proceed to answer these questions. Remember, we have only covered 2 laws, so you are only going to apply 2 laws. Okay, guys, now we are going to the answers. Remember, the question was simplify the following. For the answers, I'm going to go a bit more faster, but I'm sure that you'll be able to understand what is going on. Question number 1. In question number 1, we change our pointer now back to the pen. Right. In question number 1, you notice that I have a constant, a constant, a constant. My variables are the a squared, the a to the 4, and there is another a squared. I have another variable which is b, b, b. Now you can understand how to go about doing this, because your answer will be 2 times 3 times 4, 4 times 3 is 12, times 2 is 24. Look at my a's. There's a a squared, there's a to the 4, there's a squared. It's 2 plus 4 plus 2, which is a to the 8. If I look at the b's, that's b to the 1, b to the exponent 1, b squared. 1 plus 1 plus 2 is b to the exponent 4. Correct? Correct. Example number 2. Example number 2 is similar to the previous example, except now I have a fraction here. But don't let this frighten you. If I go across an example like this, I notice there's a constant, a constant, a constant. I have my x's and I have my y's. This is equal to 3 times 2 is 6. 6 times half is, come guys, 6 multiplied by half is 6 multiplied by a half, which is the same as 6 divided by 2, which is equal to 3. If you struggling with your fractions, use your calculator. So the answer here is 3. Then I notice I have x squared, x cubed, and x. The numbers are 2, 3, 1. Yes, x to the 6. And the y's 1 plus 2 plus 1, y to the exponent 4. You mark your own work. Ensure that you're not cheating. Remember, the whole aim here is for you to understand this work. Not to copy that down and get it correct, but to thoroughly understand it. Question number 3. Question number 3, remember there's my numerator, which I can simplify first. There's constants, there's my x's, and there's my y's. Alright, if you did this, you should have ended up with 3 times 2 is 6. Let me just help you out with the first one. That's going to be 6. That's going to be x cubed. And that's going to be y cubed. Very good. So end up with 6x cubed y cubed over the denominator. Without going any further or applying any other rules, the numerator and the denominator are exactly the same. And therefore, your answer here is equal to 1. Now, some of you might have went and used another rule, but for others, simply cancel everything off. Example number 4. Example number 4 a bit longer, but nonetheless, we can do it. There's a 3. There's nothing over here, but remember the number here is a 1. There's a 4. So the answer here is 3 times 1 times 4. X squared times x cubed times x. Look at the y's. There's the y's. So you should have 12x to the 6, y to the 6 over xy cubed. Again, guys, remember there is a 1 here. If I divide, I'm going down this way. 12 divided by 1 is 12. X to the 6 divided by x, y to the 6 divided by y to the 3. And your answer here is 12. Very, very good. X to the 5. Thank you. Y cubed. Very good. I say, guys, we are getting the hang of this. It's good. Once you get the hang of it, you can build up your confidence levels. I even forgot how many examples we had to do. Let's go over to the next example. Multiplication. A simple example. I can simplify down this way if I wanted to. Not a problem. I could have multiplied out that way. Any which way, you will still get the correct answer. In a case like this, I multiplied across. 4 times 3 is 12. X squared multiplied by x is x cubed. Y multiplied by y cubed is y to the 4. What's your denominator? 2 times 2 is 4. X times x squared is x cubed. Y times y is y squared. Very good. And now I go and apply the rule of division. Going down, down, down. 12 divided by 4 is 3. The x's, guys, cancel away. For now it cancels away. And we have here y to the 4, y squared, 4 minus 2, which is equal to 2. Perfect. Example number 6 should be our last example if memory serves me correct. This is a simple example, the division, except it seems long. Step number 1, guys, division changes to multiplication, and I invert here. First fraction remains the same. Division changes to multiplication. This fraction, remember, you have to invert. Very good. And now I go ahead and I simplify. Again, many ways to do it. You can simplify down here, or you can go across any which way. Now in this case, I went down. 6 and 12. 6 can go into 6 one time. 6 can go into 12 two times. That's where I get the half from. X squared divided by x is x. Y squared divided by y is y. Multiplied by. I go across here. 16 divided by 8. 16 divided by 8 is 2. X to the 4, x squared is x squared. Y to the 5 divided by y cubed is y to the 5 minus 3, which is equal to 2. And now I can go ahead and multiply across. A half multiplied by 2, x multiplied by x cubed, y multiplied by y cubed. And if I get this one here, half times 2 is 1. X times x squared is x cubed, and y times y squared is equal to y cubed. You have noticed that in this activity, we only applied rule number 1, which was the index law for multiplication, and rule number 2, which is the index law for division. Once you master this, I want you to go back to your file folder and look up for Exponents Part 2. That will lead us to the other rules and get us ready for the examinations. With that, thank you and look forward to seeing you next time.